I'm Dr. Incognito. In this video, we're going to investigate geometric series. A geometric series has the form summation n equals 0 to infinity of a times r to the n. So this looks like a plus ar plus ar squared plus ar cubed, etc. The number r is called the common ratio. It might be more appropriately called the common multiplier. We multiply a by r, we get ar. We multiply ar by r, we get ar squared. Multiply by r, we get ar cubed, etc. We call it the common ratio by looking at that in the other direction. Ar cubed divided by ar squared is r. Ar squared divided by ar is r. So the ratio of a term to its predecessor is r. So we call it the common ratio. So the theory of geometric series says that this series converges to a sum of s equals a over 1 minus r if the absolute value of r is less than 1. We need the ratio to have an absolute value of less than 1 in order for the series to converge. And moreover, we actually have a formula for the sum of the series. And the series will diverge if the absolute value of r is not less than 1. So if the absolute value of r is bigger than or equal to 1. So this is the theory of geometric series. Let's have a look at a couple of examples. Let's take a look at the summation n equals 0 to infinity of negative 3/4 to the n. So this series goes 1 minus 3/4 plus 3/4 squared minus 3/4 cubed, etc. The first term, a, is 1, but more importantly, the common ratio is negative 3/4. So the absolute value of r is 3/4. That's less than 1. So this series converges. It's a geometric series. It converges. And the sum is given by the formula a over 1 minus r. R is negative 3/4, and a is equal to 1. A is 1. That's the first term of the geometric series. So let's figure out the value of the sum. 1 over 1 minus negative 3/4 is 1 over 1 plus 3/4 is 7/4. So the reciprocal of 7/4 is 4/7. So this infinite series will converge to 4/7. Another example, the summation, let's start at n equals 1 this time, of 3 to the n over 2 to the 2n. 3 to the n over 2 to the 2n. So how does this one behave? When n is 1, this is 3 over 2 squared. When n is 2, this is 3 squared over 2 to the 4th. When n is 3, this is 3 cubed over 2 to the 6th. And I think from there we can see that this is a geometric series with r equals, on the top we're multiplying by 3. 3 squared, 3 cubed. And on the bottom, 2 squared, 2 to the 4th, 2 to the 6th, etc. We're multiplying by 2 squared. So here r is 3/4. And so of course the absolute value of r is also 3/4, which is less than 1, and so the series converges. this particular example, A is the first term. It's 3/4. A is 3/4, as well as R being 3/4. We had a coincidence there. So the sum of the series, in this example, S is equal to A over 1 minus R, is 3/4 over 1 minus 3/4. If we multiply the top and the bottom by 4, we can simplify this pretty quickly. 3/4 times 4 is 3, and 1 minus 1 minus 3/4 is 1/4, times 4 is 1. 1/4 times 4 is 1, so 3. The summation of this series is 3. It was a convergent geometric series, and the sum was 3. Let's take a look at one more. Suppose we start with a number like 1/2, and then we'll say minus 2/3, and then plus 8/9, and then minus 32/27, and then plus 128 over 81, etc. We'll have minus next. I've created here a geometric series. Can you see what R is? What are we multiplying by? If I did my arithmetic correctly here, 1/2 times something gives 2/3. Well, negative 2/3 technically. Negative 2/3 times that same thing gives us positive 8/9. 8/9 times that same thing gives us negative 32/27. To figure out what that should be, we could divide. Let's do 8/9 divided by negative 2/3. 8/9 divided by negative 2/3. That would be 8/9 times negative 3/2. We can cancel a little bit. 8 over 2 is 4, and negative 3 over 9 is negative 1/3. So negative 4/3 is going to be R. Let's just double check. If I take 1/2 and multiply by negative 4/3, 1/2 times negative 4/3, I will get 4 over 6, negative 4 over 6, which reduces to negative 2/3. And then multiplying that by negative 4/3, I should get 8/9. So that's how we created the 4/3 in the first place from this division. So moving on, multiplying this by negative 4/3, 4 on the top gives 32, 3 on the bottom gives 27, and we get a sign change because we're multiplying by negative. And again, 32 times 4 happens to be 128, and 27 times 3 happens to be 81. So I was creating here a geometric series with common ratio negative 4/3. R equals negative 4/3. So that means the absolute value of R is 4/3, and that is not less than 1. That's in the other category, bigger than or equal to 1, and that means that the series, this geometric series, diverges. Okay, thank you for watching. I hope you found this video helpful.